All right, I guess we're online. Hi, everyone. My name is Alan. I'm an application engineer working in the custom team, and I'll be doing today a quick demo to show you the few steps needed in order to get good data quality. Before we start, I just want to mention that there is a small delay between the time I'm speaking and the time you're watching it online. So consider a bit 20, 30 seconds of delay. If you have any questions, you can add it to the chat feature on YouTube. And I'll be at the end of the presentation. I'll be here to answer your question. So yeah, let's start this. Let me show you what I brought with me. So here I have the iFlex. So this is our iFlex probe, small version. It's our high resolution iFlex probe. It has a 34 millimeter of coverage, and it contains sensors or coils about 2 millimeter OD. I have also the manual pipe scanner. So this scanner has an integrated encoder. You can see the wheel here. And it's compatible with actually all our iFlex model. You have the small version, you have the medium version, and the large. This pipe scanner can have a range of 42 millimeter OD up to 170 millimeter OD, pipe OD. So it can cover this range of pipe OD. And finally, I brought with me also a pipe sample. So this pipe has the 40, no, actually it's a 44 millimeter OD and 55 centimeter of length. So in this sample, there is 19 defects. So I'm pretty sure you won't be able to see them, but they are really tiny defects. We have in the circumferential axis some defects, and we have in the axial axis and the 45 degrees angle. Well, actually, I have the notch description. Let me just share it with you guys. So yeah, it's 19 defects. You can see that we have circumferential ones, axial ones, and 45 degrees. I would say the most challenging ones would be the ones having 5 thou deep. This is approximately 0.125 millimeter. So imagine a 1 millimeter. Here we have a 0.125 millimeter of depth. So we have it in circumferential, axial, and 45 degrees. Let me switch back to the software and put my camera on. So I'll be taking you through some simple steps to reach a level where you are satisfied with your data. So I will start by creating my setup files. So the setup file that will be compatible with this iFlex. Then I will be performing a scan. After that, I'll be trying to adjust some parameters in order to optimize my scan and display a really good data quality in my C-scans views and my research room. So yeah, let me start by creating my setup file. So here you should start by create setup. It will take you through the setup wizard steps. You can start by, well, this page is the component definition. This is more for informative purposes, so you can indicate what material you are inspecting, what's the surface thickness, the width, and the length. The next step would be to select your probe. So here I'm using iFlex, and this is the model of the high resolution iFlex I'm using. Here is the scan definition. Actually, I will use in this case, I will use the raster scan feature because I want to display all the defects in one C-scan. And I know the coverage of the probe is 34 millimeter of coverage. So I want to be able to, in one pass, cover the circumferential and axial cracks. So what I'm gonna do is use the raster scan feature so I can do two passes and display everything in one view. So here I'm using the raster scan. Here I'm selecting the encoders. So this is the encoder of the scanner and a manual incrementation. Let me put 4 samples per millimeter. So this is the resolution you want to put in the scan direction. So here is my scan definition. I know that I have a 55 centimeter length pipe. So let me put 700 to keep it to have a longer C-scan. Here I know that I want to try to pass two coverage of my Afflex. So let us put 67.4, and here is actually the resolution that usually is indicated on all our standard encoders. So we have a 51.331 count per millimeter. I know it's inverted direction. So next, here is the data definition. So here you can adjust your hardware gain. You can add the frequencies. You can put the amplitude needed. And here you select the configuration needed for your scan. So here I will start with these values, 5, 8, and I will be choosing the short double driver topology. So this topology or configuration is best suited for my application. So to detect really small cracks, I will need to use this configuration. So the next step is the data processing. Here is where you add your filters. For now, I won't add any filter. I will show you first of all the raw data I can get. And next, the final step would be the display. I will keep everything by default. And here I can finish my setup. So you saw how simple it is to create your setup file. Going through the wizard, we tried to make it as simple as it is. And knowing that I know what I want to detect, so I know what topology, what probe I'm using, so I have everything in mind. So it's pretty fast to create your setup file. So let me now switch to the front stage. Here is where we can do all the acquisition and analysis part of my inspection. So first of all, we always need to adjust our liftoff signal. So what we're gonna do is a balance on the reference on the sample and perform a liftoff. So we have a feature where it makes life simple. This is the Liftoff Assist. I will switch my cam to show you what I'm doing. So here I have my probe. I just need to place it on an area where there is no defect. On the software, you click Liftoff Assist. So it will switch the mode. So, usually when you want to perform the liftoff, you should change your scan mode to keep it in clock mode. In this case, this feature will automatically switch between modes, and it actually has the instruction or the steps needed to perform this liftoff. So here I'm balancing. Like I said, always balance on an area where there's no defect. So I'll hit balance and start acquisition. So this is my first liftoff. You can actually do 2, 3 liftoffs just to make sure you have it right. I balance again, and perform the liftoff. So as you can see here, I'm placing my cursor on the liftoff signal. So you can see how in the Lissajou view here, there is the render all option. So this means that all the channels that you are seeing in the C-scan are displayed in your Lissajou. So it's simple, just do a rotation for both channels. And the important part is always try to keep this portion oriented to the horizontal. So after doing that, I can close this menu, and I know that my liftoff will be adjusted. So here it will switch back to encoder mode. I will show you how I'll attach my probe. So you can see I'll just put it on the right frame so you guys can see it. So here you should insert your probe like this and clip it on the scanner. And that's it. It's easy stuff. So here I'm putting it. So I already marked where the two passes will I need to do. So I just need to attach it right here, and that's it. You can see how it's well, I can feel it that it's pretty smooth. And this manual pipe scanner actually has wheels all over the circumferential, so it blocks any movements in the circumferential axis. Here I'm trying in the circumferential, yeah. Here I'm trying to twist it, and it's really tight on the pipe. So let me start by doing my first pass. So on my software, I will balance. So I know in this area I don't have any defect. Let me balance here. So I'm balancing, and now I can start my scan. So I'm doing the first pass. I'll go all over the end. So this is my first pass. Then I'll open my scanner, place it under the right direction. So this is my second pass. I marked it before, and I will attach it like that. So here in the software, you just need to go to Home tab and click on Next Pass. I will just do a balance to make sure I have the good reference. And here you can slide and till the end to have your scan. All right, stop. So here we have our data file. So I can make sure I'm saving it. So as you can notice, I will just close this menu so it can save. So yeah, by just doing the scan, you can definitely see that there is some variation in the C-scan. So at this level, so this is the second pass I did. Here we have the 6 axial cracks, and here you have the 45-degree. And for the transverse notch, it will appear in the transverse C-scan. And you can see how we were able to detect these defects. So without doing any adjustment, we have good data quality. Why? Because we are using the pipe scanner, and this pipe scanner will always keep it stable. So your scan during the scan, any movement like the manipulation variation would be won't be here because you have the iflex that will be fixed tightly to the surface you are inspecting. and you will definitely have a really stable scan. So you can see some small variation here. It's in the range of 0.2, 0.15. So what I'm gonna do is add some filters. So in order to add, so here is actually the our analysis part, let's say. I'll switch back my cam. So I will add the filters now. Here in this page, you can see the data processing. I will add low pass filter. So the low pass filter is usually used to reduce any noise coming from the instrument, to reduce any noise coming from the surface of the part you're inspecting, and also to have maybe a smoother scan. For the high pass filter, we usually recommend to have at least like the window here we are setting should be at least 3 times my longest defect. So if I switch back to see, so my longest defect here, I can see that it's point 1 inch. So this is approximately 2.5 millimeter. So at the minimum I can put is approximately 7.2. So just to make sure that this is not too tight, I will put 15 millimeters. So here you should always make sure you won't cut any signal coming from your target defects. So after adjusting uh, or placing your filters, you just need to reload the scan you took, and here it is, where you can see like the small variation we had here. Before it was 0.2, 0.15, now it was cut out, and I have a better scan this way here. So if we focus only on the axial cracks, you can see in this view how the axial and the this is the 45 degree angle. The next step you can do to optimize more your setup, you can change your color palette. So at this level, you can go and choose, let me choose the absolute, so tooth rainbow, and I can put it down to 15, a bit less than that. Let me put 70.6, and I can also switch that. I'll apply to all. So you can see how by changing the color palette of my C-scan, I was able to highlight more my defects. So you can clearly see all my defects display here, and you can see how they are looking also in my Lissajou view. And these are for the transverse notches. You can see how the signals look like. So here we have the smallest one. You can see the quality of the data we can get. So some clients they like to display this data in a 3D view. So I will show you how simple again it is to display my data in a 3D C-scan. So here I select 3D, I will choose the transverse notches. So it's just a matter of opening your cursor to have all the defects here displayed. If I change to current view, just need to change a bit my settings here. I'll rotate it. And here you can see clearly how we are able to get a clean 3D view and how the data or the defects are displayed in such view. So these are all transverse notches, and we could manage to detect everything that's required. So what you can do next is play with our analysis feature and add some detection box. So the auto detection indication, so the auto detect indication is the feature you can use to instantly highlight all your defect that were detected. So if I go to advanced detect indication, I can add it here. So let me name it circumferential based on, let me select the right C-scan. I'm looking at the transverse here. Let me adjust these, apply. So you can see how we have a alarm box, we call it, in the Lissajou view, and we are able to adjust it. So you just need to, if I go back, go to current view, edit alarm, you can see how I'm able to focus on only on my defects that I'm getting here. If you zoom out, you can have a bigger one here. So you can see how the defect, how I was able to focus only on my defects and highlight them here. Let me just adjust it again. Perfect. So that's impressive to see how easily you can adjust your parameters and easily you can highlight or like detect all the feature in one view. Well, the most important thing usually when you do an inspection is to be able to repeat the data that you have took and the data quality that you are using to see. So if you're satisfied with the setup here, you can save it. Let's say you save read only, so the operator can just load the setup file and start their acquisition. So I will just show you if I repeat my scan, I should get the same results. Also just switch my cam. So here I'm placing again my probe on the right spot, adjusting here, and I will just place it on the right spot here. So I will balance and do a quick scan to see how I can get a similar response. So I just need to balance. All right, and do my scan. So you can see how clean the defects are looking. So with one click, let's say you start your scan, you stop instantly with the auto detection feature. All the So with the auto detection feature, all the defects you are looking to detect will be highlighted in your C-scan view. So that's a pretty cool feature to use because here in that case I know my target defect and it's just a matter of adjusting my color, well actually my alarm box in order to focus only on my defects. What's the next step? So I will just clear. So here I had some report entered defect, so I'll just clear it to show you. So usually here the report section is where if you would like to generate a report, I will show you how we can generate a report. So usually you should enter your defects in this table here in the report section. And in order to generate your report and have it have this table of defects in a report, so here it's just a matter of going to analysis tab. Well, actually, assisted analysis. No, where is it? Here. Yeah. Well, I was in the right spot. Analysis tab. Here there is the report detections. So you just need to click on report detection. And if you can see, this is the 9 defects that I just triggered. You can see all the defects that were entered in the report. So now to be able to generate it, you just need to go back to the backstage here, we call it. Click on Generate Report. So here you click Next. Here you add some information. Let's say Eddyfi here. Component type, pipe. So you can add all the fields here at which site you did your inspection. If you have any comment here, you click Finish, and you'll be able to preview your it's here, so you'll be able to preview your report. So this is the first page, and you can see how in the next page you have all the defects that were entered in the report, and then you can easily generate it by by generating a Word file, creating a Word file, Excel sheet, and PDF file. So that's pretty much it. This is what I have to show you today. So again, the fuse temple it's literally fuse temple or simple steps needed to reach this level of data quality, where you can in one pass you can actually highlight all the defects you need to see in your C-scan. So I'll maybe take your questions now. So let me see what we have. I have. All right. So how fast can the pipe scanner go? Yeah, I actually forget to mention this. Well, it's always depending on how many samples per millimeter you want to display in your scan axis or scan direction. So if you want to have two, if you want to have let's say 4 samples or pixels per millimeter or more. So it's always depending on what you have in hand, but you can go pretty fast with the scanner. So you can go up to easily up to 400 millimeter per seconds. That's fast for an inspection. All right. So let me see the next question. Here we have, what is the maximum diameter able to use in this scanner? So yeah, I just mentioned this, that the range that this pipe scanner can take is between 42 millimeter and 170 millimeter of OD. So it's actually small modules that you will add to the scanner so you can cover the required OD needed. So next question. Can we use the scanner with the ready instrument? Actually, yeah, there is a version of the scanner dedicated only for the ready instrument. So it comes with a different connector where you can plug it in the ready, and you'll be able to work. It's exactly the same. It's just the connector that's changing. So it's compatible with both our instruments, the Ictane and the Ready instrument. Um, do you have any other question? Yes, that's pretty much it. I'll wait a couple of seconds to see if you have something left. So here is the data. All right, I guess that's it. So yeah, thank you for taking the time to listening to me. We are here. Well, if you have any questions, if you need any support, just contact us, and we'll be happy to take any request you have. And that's it for me, guys. Stay safe and stay beyond current. All right, bye bye.